into this equation, our original PDE. So therefore, we see here that our PDE u sub xx, that's a second order derivative of u with respect to x, and u sub tt is the second order of u with respect to t. So kita kena bezakan this function twice. So if I differentiate u once, I get u sub x, or del u over del x ni kan. I get x prime times t. So this t is held as a constant. T function is just a constant when we're differentiating. Okay, and then you differentiate twice, you get x double prime t. And if you differentiate u with t, you get x t prime. Differentiate again, you get x t double prime. Right, and substitute these values, okay, into our PDE. Right, so we get 9 times u sub xx, this one, 9 times x prime t equals to x t double prime. Yeah, betul. All right, and then now we separate. This is why it's called separation of variables. We separate the variables here, right? So we take x and its derivatives on one side, and t and its derivatives to the other side. Okay, and then because these variables, because these terms are independent of each other, so t only depends on t and not on x, and x also depend on just x and not t, then we can represent this relationship with a separation constant here, represented by gamma. Okay, this is similar to what we did in wave equation, right? By having gamma here, we can form two separate equations, right? So the first one is x double prime over x equals to gamma, which results into this, and the second one is t double prime over 9t equals to gamma, which result in this. So then we observe these two equations. Hang on. And then we observe these two equations. We find that they are both second order differential equations. The second order ordinary differential equations, and they are equal to 0 and they are homogeneous. Right, so we look at the method of solution for this type of equation from our previous topics. Okay, macam mana nak solve second order homogeneous ODEs. Right, we start with a simple one first. X double prime minus gamma x equal to 0. Right, so how do you solve second order ODEs, homogeneous ODEs? Well, we find the characteristic equation. Okay, find the characteristic equation. The characteristic equation is r square minus gamma equals to 0. And from here we find the root of this characteristic equation. So we have r is equal to square root of gamma, right? And then we don't know yet what is gamma. It's just a constant at this point. So therefore, there are three possible roots that can arise, three possible solutions that can arise from the roots, because the root can be of three, it can be three types. Okay, hang on, ada yang nak masuk lagi. Come on guys. So the solution will depend on the roots. So the roots, what are the type of roots that are available? Well, there are three types. Three solutions based on the three types of roots, and these roots depend on gamma. Right. The first type is if gamma makes the root different, and they are real number, then we get this general solution. If gamma makes the root equal to each other and real number, then you get this solution. And if gamma makes the root a complex, the roots complex numbers, and we have this type of solution. So we need to evaluate which gamma will give root, which eventually gives the solution that is non-trivial, meaning that which of the gamma will result in the solution that is meaningful, okay, non-trivial. Kalau if it's non-meaningful, then we don't look at that, tak penting. For instance, kalau if our solution u xt ni daripada gamma ni dapat roots, and then the roots give us the solution gives us x in this case, and if x is found to be equal to 0, if we put 0 in this PDE solution ni, uxt ni, then you get uxt equals to 0. So that is like that's non-trivial. It's like, you know, getting this here, u equal to 0. So tak penting, right? So you don't need to know that. Memang dah tahu lah pun. So we want to find the root that will give us a non-trivial solution, right? Now, in order to evaluate the roots, we use boundary condition given to us, okay? We use the boundary condition given to us. Right, so let's look at the first boundary condition. Sebelum tu, before that, let's look at the possible roots dulu. So the possible roots are, you know, if you have the root to be apa ni? Sebenarnya saya nak terang ini dulu. Okay, tak apa. The root to be a positive number. So how can this be a positive number? So if you have this a positive number, then you have two roots which are different from each other. R1 dia tak sama dengan R2 for this case, and they are real numbers, kan? Okay, that is if this is positive number. Okay, and then secondly there is a so I write here the root can be in order for that roots to be distinct, okay, different and from each other, then you need this root to be either to be positive and negative square root of gamma. Ini negative, positive, negative. Kita akan dapat dua distinct root. Now for roots to be real and equal number, maksudnya if you want the roots R1 to be equal to R2, okay, for the second case ni, then this has to be, gamma has to be 0. Because if gamma is 0, then R1 is 0, R2 is also 0. So therefore R1 equals to R2. Okay, so in order for R1 to be equal to R2, gamma has to be 0. So we have this as a second possible root. And the third one, in order for the root to be a complex number, then this gamma has to be a negative number. Kalau negative ni, then we won't get a real number. So because a negative of something is the square root of a negative number is always a complex number. Okay, complex number. So we put a negative sign in here, and then R1 sama dengan positive the square root of negative gamma, and R2 is equal to the minus of a square root of gamma. Alright, so that will give us a complex solution. Then we go on to find the alpha and the beta from the complex number given to us. Alright, so and then we're going to evaluate and find the root that will result in a non-trivial solution. Alright, so for that we use the boundary condition. So the boundary condition, the first boundary condition says that u at x equal to 0 at any given time, as long as it's more than 0, okay, is of course is x of x, if it's u, because our assumption earlier, remember, we say that the solution u x of t is equal to x of x times t of tn. So at x equals to 0, which says the value of u is equal to 0, and then x at x equal to pi, the value of u is also equal to 0. Okay, right. So for this case, t cannot be 0 because it says here t more than 0. Okay, Right, so therefore x naught x at x equal to 0 has to be 0, and x at x equal to pi has to be 0, because these cannot be 0. Okay, syarat dia t ni tak boleh 0 kan. Alright. Okay, so then we try each cases. Right, for instance, we try first of all gamma equals to 0, which will give us equal roots. Okay, so if gamma equal to 0, then r is plus minus the square root of 0. So therefore we have here, we substitute this into our boundary condition, right? So if we for this root, the solution for x is this, the first one, sorry, the second one, so here y, I write it in this form. Y, I take this one first. Y is equal to a times x times e to the power of rx. Okay, ini y or rather x ni, x is equal to a times x times e to the power of rx plus b times e to the power of rx. R is 0. Okay, r is 0. So I substitute this. Masuk, and then I equate this equal to 0 because I'm evaluating at boundary condition, at this boundary condition where x is equal to 0. Okay, so x here is equal to 0. Right, so a times 0 times this is 1 plus b times this is also 1. Okay, e to the power of 0 is 1 equals to 0. So this is 0, this is going to be 0. So we have 0 plus b equals to 0. Therefore, we get b equal to 0. And then we evaluate the second boundary condition at x equal to pi. So we substitute this. Now we know that b is equal to 0 already. So therefore, this term is equal to 0, right? But e to the power of this is square root of 0. So e to the power of 0 pi, 0. So therefore, this becomes 1. 1 times pi times a. So pi cannot be 0. This is 1. So therefore, in order for this term to be 0, then a has to be 0. So we have b is equal to 0 and a equal to 0. Therefore, we have a trivial solution, and we can cross this out. This is the root. This root gives this gamma. The value of gamma here equals to 0 will give us a trivial solution. Then kita tak guna this one. All right. Then we go on to evaluate the second possible root, or the second possible value for gamma. All right, so the second one is this one. I'm taking this one. R equals to plus minus square root of gamma. This will give me R1. Okay, this will give me R1 is equal to a positive of square root of this. And then R2 is equal to a minus square root of gamma. Ada cara lain nak cari ni, but I'm just explaining this one. Okay, setelah textbook ada cara lain untuk explain. Alright, so we have two values of R, which is R1 is positive, R2 is a minus. Right, so and the solution is this guy here. Okay, x is equal to a times e to the power of R1x plus b times e to the power of R2x. This guy. Okay, this is a solution for this root. And then we go on to do the same. We apply the boundary condition. So at x equal to 0, this is going to be equal to 0, and this is going to be equal to 0. So therefore, a times e to the power of 0 is a times 1. B times e to the power of 0, that's also this also 1. So it becomes a plus b, and that is equal to 0. And therefore, we have b equals to minus a. And then we apply the second boundary condition where x is equal to pi. And x is equal to pi, okay, we substitute x equal to pi into this general solution and evaluate. So we have here, right? But b is equal to minus a, so I substitute b equals to minus a here. Then I take out the a, right? I have this. Right now, the boundary condition says that x at x equal to pi has to be equal to 0. So therefore, this term, this has to be equal to 0. Now we have either a equals to 0 or this guy here equals to 0. Now for this guy to be equal to 0, then this gamma has to be equal to 0. Betul tak? Barulah bila so that ni e to the power of 0 jadi 1. Now e to the power of minus square root of 0 jadi e to the power of 0. Ni pun jadi 1. 1 tolak 1 kosong. So barulah ini jadi kosong kan. That's for this to be 0, then gamma has to be 0. But gamma cannot be 0 because gamma is 0 consider dah kat sini. We've already considered that. So and that gives us a trivial solution. So gamma cannot be 0 here. Right? So if gamma cannot be 0 here, then only a has to be 0. Right? So a has to be 0 in order for this term to be 0. If a is equal to 0, then we have b also equal to 0. Thus, we have a trivial solution as well. So the second case also gives us a trivial solution. Now our chance lies in this guy, okay, the third case, where the root is a complex number. Kalau tak juga tak boleh kan. So nak tak nak yang ni kena juga bagi dapat solution. So we evaluate case T, where gamma is equal to where the root gamma itulah gamma. So our gamma is equal to root, yeah. So our root is equal to a square root of minus gamma. R tak nampak macam R. Betul lah. Tak kisah pun. Tadi sekejap masuk begini. Alright, for this case, gamma, the value of gamma we use is square root of minus gamma. That will give us the root to be a complex number in this form, alpha plus minus imaginary number times beta. Alright, so comparekan, we have r equal to plus minus imaginary number times minus square root of minus gamma. Alpha equal to 0. Okay, alpha equals to 0. And beta is equal to square root of minus gamma. Now the solution is, the general solution is this guy here. Okay, ini the solution. So our x of x is equal to e to the power of alpha x times this term. Right, because alpha is equal to 0, this whole term becomes 1, we're only left with this term here, and then beta is replaced with square root of minus gamma, like so. Then we go on to apply the boundary condition. Applying the boundary condition, first boundary condition at x equal to 0, the value of x, the function x is equal to 0. So if you substitute x equal to 0 into this solution here, you will see that you get a times cosine 0 plus b times sine 0. And sine of 0 is 0. So this one becomes, this whole term becomes 0. You have a equals to 0. Okay, so we have a equal to 0. Now, nak cari pula what's b. So we use the second boundary condition, where x is equal to pi. Alright, and a already known is equal to 0. So therefore we can cross this out, and we're left with b sine square root of minus gamma pi equals to 0. Alright, we have this here. Right. Okay, now if you look at this function here, if you plot a sine function against x, alright, against x, tunggu dulu, sebelum tu kita kata, okay, now this is a equals to 0, right? Now if we get b equals to 0, if we get b equals to 0, then we will get x of x equal to 0, and then our u xt equal to 0. Our solution will become a trivial solution again. So b cannot be 0. Kalau b 0, habis kita tak ada solution. So this guy has to be 0. Sine square root of minus gamma pi has to be 0. Now, when is sine square root of gamma pi equal to 0? When is the sine function equal to 0? So if you plot a sine function, okay, you will see that sine is equal to 0 whenever the x value is equal to the multiple integral of pi. Okay, for instance, x sama dengan if x equal to pi, x equal to 2 pi, x equal to 3 pi, and so on and so forth, then the value of this sine function is going to be 0. Barulah sine x jadi 0. So this whole thing, okay, has to be this square root of minus gamma ni has to be multiple integrals of pi in order for this part this sine function to be 0, kan? Okay, sebab b tak boleh nak 0 ni. Kalau b 0 habis kita. So ni je yang kena 0, right? So therefore we can replace this square root of minus gamma with n, where n is a integer. Okay, meaning that if n equals to 1, then this term becomes sine 1 pi. If n equals to 2, this term becomes sine 2 pi, 3 pi, and so on, sine 3 pi, sine 4 pi, and so on and so forth. Then those are the only conditions which gives us this equal to 0. Okay, so we can substitute this with n, right? So our gamma becomes minus n squared from here, from this relationship. We now find our gamma to be minus n squared, where n is a series. Okay, n is a series of integers. Integer ke integer? Okay, right? So we substitute this gamma into this. Gamma equals to minus n squared into this. Mana ni? Gamma equals to minus this. Betul kan ya? N, kita nak cari n. Yeah. Okay, substitute this into n. So we have here b sine, ada b sine n. Okay, this is equal to n times pi. Okay, that's equal to 0. Now, because this is a series, and this b constant has to be a series constant. Dia pun kena tukar jadi constant because it changed dependent on this value of n. So we now use b sub n to represent a series constant. Okay. Right. So we have now x of x, okay, is equal to ni kosong plus b. What is b? Plus b sine this. Okay, substitute this into our x of x. Kita akan dapat x of x equal to b sub n sine n x, where n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 semua integer. Okay, so kita dah jumpa x, kita dah jumpa x ni. We have now found this, right? Part of the solution. Now we're going to find t, right? How do you find t? Well, t is just another second order differential equation, right? So to solve t, you use the same method as before, but this time we've already found the value of gamma. Which gamma to use basically. Kita dah tahu dah. Kan? Sebab we've done that for when we were solving x. So we've done this. So we don't need to try every solution. Okay, we've already got the solution, or rather we've already got the value of gamma. All right. So you go on to solve this second ODE ni, so with gamma already known, kita dah tahu dah gamma equals to minus n square. Right. So to solve this, we do again find the characteristic equation. So r square minus 9 gamma equals to 0, and then this will result in because gamma is a what you call this, because the root is a complex root, and with gamma equals to minus n square, we can just write the solution like so. So here is the root is plus 3 times this. All right, alpha equals to 0, and beta equals to 3 times square root of minus gamma ni, ataupun square root of square root of n ni kan. All right, then we substitute this beta into our solution, into the general solution. So what's the general solution? Well, yang sebelum ni a cosine ni kan, right? A cosine square root of minus gamma x plus b sine square root of minus gamma x. So because a and b is used up, so I now use c and d, okay, to represent the integration constant, the integration constant solution itu kan. All right, so I use t of t is equal to c cosine beta t plus d sine beta t. Alpha is equal to 0, man. All right, now because I now know already the value of beta, I just substitute the value of beta in here. Okay, substitute the value of beta in here. Right. Okay, so that's my t. So I can now substitute x, which is this, and t into my, which is this, into my solution. So you have u x of t is equal to this x b sub n sine nx times t, which is c sub n cosine 3 and t plus dn sine 3 and t. All right, and then again, because this is, if you see, if you multiply this b sub n times c sub n, this is a constant, series constant multiplying with another series constant. So a constant times a constant is just another constant. So I substitute this b sub n and c sub n, the product of these two, I substitute with small b sub n. Sine nx cosine 3 and t, sine nx cosine 3 and t, plus, and then b sub n times d sub n, that's another series constant. So I replace that with b sub n sine nx times sine 3 and t. That is my u x of t. All right. Okay, now since this is a series, solution, okay, solution ni adalah bentuk series, maknanya we have a lot of values. So the superposition theorem says that because the equation is linear and homogeneous, then we may form an infinite sum of all the solutions. Kita boleh jadikan semua solution ni sebagai satu fungsi sum, okay? Right, so we write that by having this, putting this sigma here, which shows a summation sign, a summation from n equals to integers, n equals to 1, 2, 3, 4, 5, 6, 7, 8, dan seterusnya. All right, up to infinity. All right, and then put the function, this function here, into this, okay, under the summation sign, right, like so. All right, so this is our solution. All right, now is it finished? Well, we're kind of halfway through, because we still need to find b sub n and d sub n. What are these series constants? And in order for us to complete the solution, we also need to find b sub n, d sub n. All right, so how do we do that? Well, we now use the other information given to us, which is in the form of initial conditions. Right? We now use the initial conditions to find the value of B sub n and D sub n. So the initial condition, the first initial condition says that u at any given x at t equals to 0 is equal to a function f of x, right? A function f of x. Now, if you substitute t equals to 0 into this solution, so this is going to be t equal to 0. This is t equal to 0 kat sini. So we have b sub n sine nx times cosine 0, which is 1, plus d sub n sine nx sine 0, which is 0. Right? So this becomes 1, this becomes 0. And then we have the function ux at 0 using the first initial conditioning. We have b sub n sine nx sahaja. Right? That is the first condition. All right. Now, all right. And then, okay, I'm going to skip this part first. Skip dulu kat sini. Now, we'll evaluate this one. Okay, b sub n nanti kita cari. Now, what about d sub n? All right. So we use the other initial condition. The second initial condition says that u sub t at t equals to 0 is equal to 0. And the velocity of the string, okay, the velocity of the string at t equals to 0 is equal to 0. So we use this information to find our d sub n. So how do you do that? Well, you have to differentiate this. Right? So in this case, you can differentiate under the summation rule. Just differentiate macam biasa these terms. Okay, kalau kita differentiate these terms, we get this minus summation macam biasa. U sub t is equal to so you differentiating u bezakan yang ni this term ni kita bezakan terhadap t saja. Bezakan terhadap t. So if you differentiate with respect to t, whatever terms yang that is not dependent on t becomes a constant. Okay, for instance, this sine nx, all these terms, these are just constants. You're only differentiating the terms that are dependent on t. Right, so u sub t is equal to minus 3n, okay, times this, times b sub n sine nx, sine nx, and then times, and then differentiate the other one, differentiate this cosine. So differentiating cosine becomes a negative sign. So you have negative here, right? And then do the same here for this part. All right, so and now evaluate at t equal, once you differentiate dapat ini, evaluate at t equals to 0. So sine of 0 is 0. So this whole term becomes 0. And this is cosine 0. Cosine 0 becomes 1. And we're left with 3 and d sub n sine nx, like so. This is equal to 0, complying to the initial velocity. Okay. Now we can evaluate this. How do you find this? Well, there's an easy way. The hard way is to do a Fourier series and find the value of dn, find the coefficient d sub n. But there's an easier way. If you look at this, you have 3n times d sub n times nx. That's equal to 0. Now, n is 1, 2, 3, 4, 5, 6, 7, n are integers. So they're not 0 because 3 times n can never be 0. 3 times 1 is 3. Okay, so because n is not 0, then therefore this cannot be 0. Also, sine nx, okay, sine nx is also not 0. Okay, because here x is not 0. So sine nx, because n is not it's not 0, then therefore this is also not 0. So d sub n has to be 0. Okay, so tanpa without even having to carry out Fourier series computation, I discovered I can show, I can prove that d sub n is equal to 0, right? So now d sub n is equal to 0, meaning that our solution becomes just this part. because d sub n is equal to 0. Saya boleh eliminate yang ni. Okay, now come back to this b sub n. Kita tinggal b sub n saja nak cari. Alright, so how do you find b sub n? Well, you look at this b sub n times this. We look at the first boundary condition where it says that u of x at t equals to 0, the initial condition is equal to f of x. Okay, it's equal to f of x. Now, then we substitute t equals to 0, we get this term equals to 0. We're left with f of x, u sub ux0, which is equal to u ini. So this is my u x 0, okay, is equal to f of x, and is equal to this term here. Okay, b sub n sine n x. So if you look at this is a Fourier series function. Okay, it is a Fourier series function. We can go on to find f of x by finding this b sub n. Okay, the Fourier coefficient b sub n. Right? So, but if in order to do that, simple, kita tengok saja. We use our knowledge of Fourier series and then we find b sub n. B sub n, as we know, is equal to 1 over L. Tengok balik B, so from Fourier series, b sub n is equal to 1 over L, 1 over 2L, 1 over L, 0 to L, function f of x times sine nx, and so on and so forth. Okay, so cari apa ni? So we're gonna solve this by finding the Fourier coefficient b sub n. But if we look at the interval, kita tengok interval, this function is defined between 0 to pi, if you remember. So our function is defined as 0 to pi. Whereas for Fourier series, kalau kita nak buat Fourier series, what is the time interval? Kalau kita nak buat Fourier series, kita mesti ada minus pi to pi. Okay, baru kita boleh buat Fourier series. But we only have 0 to pi. And therefore, this become a half series range. So you use a half series solution. So a half series solution is to find same method, but b sub n is equal to 2 over L. Kalau full series, kalau bukan half series, kalau full series is 1 over L. But this is half series, so we do b sub n equals to 2 over L, and then integrate between 0 to L. Otherwise, kita kena integrate between minus L to L kan. This one because it's a half series, and then we integrate between 0 to L, dan ini darab dengan 2. Okay, that is assuming that this series is a an odd function. Okay, meaning that I assume this to be an odd function. What I'm doing here is, saya tulisnya sini, plot sikit. Ini kita punya initial condition asal. It's like this. This is pi, this is 0. This is f of x. This is half of pi, kan? Pi per 2. So, in order for me to complete to do a Fourier series, because this is just a half series, so I assume that this is an odd function like so. Okay, I assume that this is an odd function. Okay, so an odd function can be represented solely by a sine function. Okay, because this is an odd function, so it's equal to it can be represented by a sine function. Then I go on and find b sub n, okay, the Fourier coefficient, right? And so how do I do that? Well, because we have two values of f of x, and from our initial condition f of x is equal to x between this and this, and then equals to pi minus x, pi blah. Okay, f of x is equal to x for this and this, for this to this, from 0 to pi pi half, and then pi minus x from pi half of pi up to pi. So in order for you to find the Bn using Fourier series, you have to do two integration. Right? So from here, L is equal to pi. L is equal to pi. So therefore, our B sub n is equal to 2 over pi. Integrate between 0 to L, which is pi, and then f of x, whatever it is, sine nx dx. This f of x is two values. There's two values for f of x. One is equal to x, and the other one is equal to pi minus x. So in order to do this, you need to separate. You need to substitute f of x ni equal to x from 0 to pi over 2, and then campur dengan ni integrate pi minus x pula, for pi over 2 up to pi. So kena ada dua ni integration ni. Right? Then we get the value of b sub n. Right. Okay. Then coming back tadi, recall tadi kita dah kenal pasti, we've already acknowledged that d sub n is equal to 0. Alright, so d sub n is equal to 0. B sub n is determined from your Fourier series, right? And then we now know the complete. We now substitute the values with into our uxt. Masukkan dalam ni. Okay. Alright. So by solving this, by finding the value of b sub n from your integration, and then substituting into our solution, you have the final solution to be uxt equals to 4 over pi summation of n up to infinity, where n is a series of odd numbers. N 1, 3, 5, 1, 3, 5, 7, and so on and so forth. And only odd numbers is used. Alright? And then 1 over n squared sine pi over 2n sine nx cosine 3nt. This is the solution, the final solution, once you know your b sub n. So you have to do the integration to find b sub n. Okay. Right? And this solution can also be written simplified. Okay, simplified by taking this sine pi over 2n. I can substitute this with minus 1 k to the power of k minus 1. You know why? Because this sine pi over 2 times n, if you increase then, okay, sine pi over 2n, for n equals to 1, 2, 3, 4, and so on. So this value becomes if n is equal to 1, this is sine pi over 2. Sine pi over 2 is equal to minus 1. All right, and then if n is equal to 2, this becomes sine pi. Sine pi is equal to 0. And then n equals to 3. This becomes sine 3 over 2 times pi, which is positive 1. And then n equals to 4. So 4 over 2 times pi it becomes half of pi. So that is 0 again. And it keeps repeating. Minus 1, 0, plus 1, 0, minus 1, 0, plus 1, 0, and so on and so forth. So this behavior, okay, can be represented by minus 1 to the power of k minus 1, where k is 1, 2, 3, 4, 5, so on. For this case, we don't want this. Kita tak mau nilai sama dengan 0. Betul? Alright. because if this sine pi over 2n is equal to 0, then this becomes 0. When this becomes 0, this whole term becomes 0 and everything becomes 0. So therefore, u becomes 0. So therefore, it's a trivial solution. So we cannot have this sine pi over 2n is equal to 0. We need to eliminate this 0 and take only this. Kita nak yang ni sahaja, right? So we can do that by substituting this term. Kita gantikan dengan minus 1 k minus 1 to the power of k minus 1. So masuk dalam ni, ganti. Alright, so this k ni apa dia? What's k? Well, k is defined like this. N is equal to 2k tolak 1. That is k. Right, so k is basically, what is it? N minus 1 over 2. This. Square, sorry. Right. So sampai sini dah boleh dah. This is just to make it more apa ni, cantik lagi, more elegant. Comel sikit dia punya solution kalau kita ambil itu. Okay. Right. So what do we have? We have this this as our solution to our wave equation, right? So what does it describe? What does our wave equation describe? Well, as I've explained earlier, when t is more than 0, our string will start moving in a wavy pattern like so. So this the displacement of the spring at any given location, here, mana-mana saja, at any given time can be represented by our solution uxt. Right, so this solution describes the displacement of the string along the x-axis at any given time. Right. Okay, any questions? Ada soalan? Okay, so yang ini I want you to complete this along with any solution dah ada kan, so you can use ini and complete also this. Okay, saya nak buat ni practice finding this. This can be a useful exercise for you for Fourier series. Okay, so it's a useful Fourier series practice. Finding b sub n this. So what you do is you try to integrate this by doing integration by parts. All right, trying to integrate this, and then so that you can complete the whole solution, and then this is part of your individual assignment for this final topic. Saya ada bagi individual assignment in author system. That is just your practice for this chapter, this topic. Alright, ada 2. Solution is here. Ni saya ada tunjuk kat sini. I have it here, but I'm not. Saya tak akan tunjuk because I want you to do it on your own. So basically, this is what I did to compute Bn. We are not snap screen. So I extend it to be a half series range. To find Bn, I use this formula to find the coefficient of Bn, and then I need to, and then I end up having to do integration. Okay, so when I do integration, this is what I get. Okay, this is what I get. I get B of n, and then I introduce that value of k. So and then I substitute everything into my solution. Okay, right. So this is ni lah. Lebih panjang sikit lah kalau awak nak buat. Alright, any questions, guys? Boleh faham Penerangan ni panjang tapi step dia tu sikit je. And you will notice that actually, you know, if you look at the solution to heat equation and solution to heat equation and wave equation, it always ends up, you know, when you're trying to eliminate the trivial solution, bila kita nak buang trivial solution kan, selalunya the root is always complex root. Okay, banyak dalam soalan you will get the root to be a complex root. Yang first two case ni always end up being a trivial solution. Kalau awak tak test pun tak apa. Go away straight away. Kalau dalam exam kan, straight away go to case 3 ni, where the roots are a complex number. Faham tak? Sebab yang okay, case 1 dan case 2 biasanya trivial solution. Okay, yang root yang bagi solution biasanya yang complex number. Itu tips lah. Heat equation pun sama. Selalunya yang roots yang bagi the roots that will result in a non-trivial solution is that complex root. Okay, right. And you need to understand both equations. You need to understand this topic. You need to practice and try and solve it, because it will be a compulsory question in your final exam. Wajib jawab ni, tak boleh tinggal soalan ni. Fourier series dengan partial differential equation memang tak ada pilihan, you have to jawab. You have to jawab. Right? Okay. So final exam. If I were to just brief you on final exams, so the final exam will be done in author. Fully in author system. Melainkan kalau ada masalah sangat, awak boleh directly contact me through WhatsApp. WhatsApp tu maksudnya awak standby WhatsApp ataupun email. Okay, just in case awak punya author crash, bukan crash, author tak crash, in case ada apa-apa yang emergency berlaku, then you have to let me know during final exam. So the final is on 31st of January. So and we've got another 10 hari lagi kan. Author system, there are 6 questions. 6 questions, and then these questions have 2 parts. Part A, Part B. Okay, saya dah arrange question ni more or less ikut chapter kita. So part A, there are 4 questions. Q1, Q2, Q3, Q4, and then part B, Q5, Q6. Okay, so part B ni adalah Fourier series dengan partial differential equation. The rest is tajuk yang awal-awal. First order, second order, Laplace transform. Okay, a mixture of them. And then this first question, you have to answer 3 questions. Okay, select salah 3 daripada yang ni. And this one you have to answer all. Answer all questions. Okay. Okay. So now for the author system, in the author system, I've enrolled everyone into PDE 24303 final exam. Okay, final examination. Bukan yang author, bukan yang classroom yang kita sekarang ni, tapi ya dia the classroom khas untuk final examination. Saya dah enrollkan semua orang dalam ni. Okay, ni bukan saya punya method ni adalah yang disediakan oleh universiti punya. Okay, so semua orang kena check dia orang dah enroll belum dalam ni. Then the question will be released one by one on the date of the exam. Okay. Apa lagi soalan berkenaan dengan final exam ni? Siapa nak tanya apa-apa? Alright, so mula-mula you have to be there, you have to sign a you have to sign a declaration. Okay, declaration is a soalan objektif. Dia dalam bentuk soalan objektif. You answer yes. Okay, you have to answer yes for that declaration form tu. So tak payah nak upload apa-apa dah. You just klik dekat situ, declaration tu, jawab soalan dia, dapat yes, then that's it. Okay, and then you will be given instruction, final exam instruction. Alright, so that explains to you how it's conducted and everything. And then there's also, you will also be given formula. So these are all given to you before the exam starts. Exam starts pukul 9 pagi. So 8.45 tu dah start, dah ada dah semua ini. You can start downloading before 9 AM all this. You can download semua in PDF. Okay, semua yang boleh download tu semua dalam bentuk PDF. Alright, including formula. So you get PDF, formula given to you in PDF. So you can download, you can print, you can do whatever you want. And then the questions will be released one by one. Okay, so every question is given 35 minutes answering time. And 10 minutes. 10 minutes upload. So panjang masanya untuk jawab ni. Okay, 10 minutes to upload. So total of 45 minutes. 45 minutes for every question. So we finish at around 1:20, 1:30, something like that. Right, so if you have time, grab, you will have time to grab food ke apa ke semua tu. You have time. Okay. Now, once you finish all the questions, right? Once you finish all the questions, you have to select. This is 4, and then 5. You have to select your answers. Select answers. There's a separate sheet, PDF. There's a PDF you have to download, and then you have to tick. So dia akan bagi macam soalan, macam exam biasa tu, ni soalan apa, you have to select which questions, which 5 questions that you decide to submit. Well, yang ni memang kena select lah. Right, so you have to, this is wajib, so memang ni compulsory, so this will be submitted. But this you have to select 3. So you have to select either 3 or amongst this. Okay, meaning that if you are confident with answering question 1, question 2, question 3, for instance, if you're really confident that you have answered this, you don't even have to answer question 4. Tak payah nak jawab pun soalan 4 kalau yakin. Just tunggu sampai soalan 5 dan 6. Okay, then pilih soalan yang jawab. Then you have to submit this. Itu saja. Alright, any questions? Any questions now? Soalan keluar serentak kan? Nope. Soalan release ikut masa. Questions will be released according time. So first question 9 o'clock up to 9:35, and then 10 minutes to upload. So basically you have 45 minutes for every question. And if you and then there will be strictly no late submission. Sebelum ni test, kalau lambat awak hantar, if you send late answers to me during test, then you can still get through, but it appears in my system as late submission. That is for test, but for final exam, you cannot even upload your answer, meaning that 45 minutes is ultimate. So by 35 minutes, you have to finish answer, and that 10 minutes is used for you to attempt to upload your answer. So there will be no apa ni, tak ada apa, tak ada kompromi dah in terms of late submission. If you exceed 45 minutes, you cannot even send your jawapan. Tak boleh nak jawab, tak boleh nak hantar langsung. Dia terus tutup saja. Sistem tu akan automatic tutup. Okay. Alright. So tak, jangan buat apa macam selalu buat, tunggu nak tiru kawan lah apa benda tu. Tak payah nak cubalah yang tu. Takut lewat tak boleh hantar. Betul. Alright, Huzaimah tanya, if I don't feel confident to answer question 2, then I skip it, then unfortunately question 3 and 4 are also hard. There's no second chance for me to try to answer number 2? No. The answer is no. Okay, in these circumstances, no. Dalam situasi sekarang, di mana online system ni tidak membenarkan untuknya tu. Alright, so kalau katakan soalan 2, skip. Susah ni soalan 2, jawab soalan 3 je, duduk di like, keluar soalan 3 pun susah. Oh nak decide nak buat soalan 2 balik, tak adalah. Because kalau rasa soalan 2 tak boleh jawab, bila pergi ke soalan 3, soalan 4 pun tak boleh jawab, then what makes you think that you can tiba-tiba dapat ilham jawab soalan 2 ke? No, that doesn't work like that. Okay. So there's no, you cannot return to previous questions. It's just straight sequential, maksudnya straight habis. Okay. Soalan-soalan tu boleh download maksudnya you can download the questions into PDF to keep it. So you have to do you do that, because the system might apa ni, when might close after every question finish, then the system closes that question and you cannot download anymore. So kalau nak download mula-mula tu, memang kena download pun, sebab kalau tidak tak download tak nampak soalan. So you have to download. So everybody has the question so that they can in the end they can remember which question they want to submit, which they want to choose ini for marking itu. Alright, lagi? Tak ada dah. Sekejap, ambil attendance. This is section 1. Okay, kalau tak ada soalan, no, sorry. Kalau tak ada soalan, then that brings us to the end of this course. Okay, tamat kursus ni, subjek ni, tamat subjek ni. Jadi I will end my lecture with certain quotes, okay, beberapa quote daripada orang-orang makhluk-makhluk terkenal pasal matematik ni. Mickey Mouse dia kata, arithmetic is being able to count up to 20 without taking off your shoes. Okay, tu Mickey Mouse cakap. Kemudian Descartes ni dia cakap, mathematics is a more powerful instrument of knowledge than any other instrument that has been bequeathed to us by human. So mathematik ni human discovery yang antara yang paling penting sekali di dunia ni. Right, so okay, Tuhan bagi matematik kat kita ni sangat-sangat memudahkan hidup kita. And then the essence of mathematics is not to make simple things complicated, but to make complicated things simple. So you've learned that throughout this course, you know, you can you predict the movement of springs, for instance, or predict the movement of waves, for instance, through mathematics on a piece of paper. Okay, tak perlu nak pergi set up eksperimen, ambil kamera apa bagai semua tu. Kita just boleh guna mathematics and we will we are able to basically predict the future. Define the location of the string ataupun the location of the movement of a spring or stuff like that. Okay, hanya atas kertas saja, tak perlu nak pergi buat the actual thing. And then finally this ini dulu punya code, masa tak ada online, sekarang dah ada online. A math student's best friend is Bob, but Bob is also not there during exams. Bob is back of the book. Okay, sekarang ni Bob dah because you're doing online exams, so Bob is always there to help you. Right. Ni ucapkan terima kasih atas kerjasama semua pelajar. Kita ni unfortunately we're not able to meet face to face at all this semester, but yeah, it is what it is. So again, I tried my best given the circumstances. I did really try my best to conduct this course. Of course, I will improve it in the future. Sudah tentu ada kelemahan-kelemahan tertentu, dan untuk kalau ada kelemahan tu saya minta maaf. And then I wish you all the best. Good luck in your exams, and then hope to see you in other courses dalam masa akan datang in the future. Okay. Saya tak tahu bila dia orang tutup sistem untuk penilaian pensyarah tu, penilaian pengajaran tu. Kalau ada yang belum buat lagi dan boleh buat, boleh isi penilaian tu, bagi komen, bagi cadangan apa-apa, bolehlah buat demikian. Boleh saya gunakan feedback daripada kamu untuk improve saya punya pengajaran saya di masa akan datang. Okay. Rasa itu saja kot kali ini. Sekali lagi terima kasih atas kerjasama semua. All the best everyone. Alright. Bye bye. Assalamualaikum.
Waalaikumsalam.
Okay, Doktor.
Thank you, Doktor.